So you can't remember how to determine the type of bond using the electronegativities. Well, let me tell you, it is really easy to do, so we don't have to worry about that. I'm going to do two examples for you, and no, they're not the examples that are on the paper. But with this examples, this should work out fine. First of all, you need two charts. You're going to need the electronegativity periodic table, which is on 161 in your book. That's on the right there. And the other chart you need is on page 176 in your book. So you need these two things, 161 and 176. Okay, now, to determine the type of bond. Bonds, remember, are how the atoms are going to share or trade or do whatever with their outer shell electrons. So that's what electronegativity is, and negativity is how bad they want the electrons, right? It's their pull of electrons. So this will determine which atom wants the electrons more and how the pulls of the two atoms will affect the types of bonds. Before we do this, let's look at the types of bonds. Now, I have my little short, teeny little versions, and you know these. You should have these memorized. If anything you ever memorize in your life in chemistry, these are things you should know. Ionic is going to transfer. So think about that. Transfer electrons, and these are valence electrons. Transfer electrons because one atom can pull on that electron, has a much higher electronegativity than the other. So they transfer the electron over. For this to happen, one of them is going to have to be a metal, which has a very low electronegativity, and one is going to have to be a non-metal. Right? High electronegativity of the non-metal, low electronegativity of the metal. Remember, non-metals want to gain electrons, metals want to lose electrons. Covalent. Covalent are going to share electrons. All right, so this means they're both going to be pulling on those electrons about the same amount. So for this to happen, they're going to have to be both non-metals because they both want to pull an electron. Oops, I put it in. Both non-metals, okay? So they want to gain electrons. They both want to pull in electrons, but they're both pulling on about the same amount, so they have to end up sharing them. Now, sometimes it's not a fair share, and it's an it's an unfair share, right? And so one of them has a little bit more electronegativity than the other, but not enough to pull it away. These are usually between nonmetals also, but there's a lot of variance in this one. And then finally, there is the metallic. And the book uses the sea of electrons. I sometimes say the hot potato of electrons because the electrons, nobody really wants them, and they just get juggled around between. And these, of course, would have to be in metals. Okay, I hope that helps. Now let's look at what we're supposed to do. Okay, ooh, I picked methane and ammonia. Pretty lame choices, but let's do it. Now, remember, this is only talking about the bond between one carbon and one hydrogen. Right? All these are going to be bonds, right? There's going to be 4 different bonds, but we just want to find the pull on the individual bond. Okay, so we go on to our chart and we find the electronegativity for carbon. There it is, 2.5. And then we find the electronegativity for hydrogen, 2.1. Okay, so let's put those down. So we have 2.5. I always write the one that's the highest first because I have to subtract these. So 2.5 minus 2.1. And that equals 0.4. Oh my gosh. All right, so 0.4 is our number, and that's going to determine the type of bond. So let's look on the chart. Ooh, 0.4. So it has to be between 1.7 and 0.3, and it's going to be a polar covalent bond. Now, we just going to do the easy way. We're going to write PC. Oh, it's politically correct. No, it's polar covalent. All right. Now, the other one's probably also going to be polar just because, yeah, I just know it probably is. So let's see. We look up. We're just doing one bond. It doesn't matter which of these bonds we do. Hey, let's do this one. So N, look at the chart. N is 3. H was 2.1. Hey, what a memory. And that equals 0.9. And so, again, on the chart, come here, chart, that would be between that list, and that would be polar covalent also, 0.9. If it's above 1.7, it's ionic. So if I pick sodium chloride, it would have been 3 minus 0.9, which would have been, what, 2.1? That'd be ionic. So that's how it works. Not too bad. Just remember, the only tricky thing is you're only doing one bond. You're not timesing the thing. You're not timesing this number by, I'm not going to say it. Yeah, I will. You're not timesing that by 3 because there's 3 hydrogens. You're only talking about the individual bond, so don't do that. Okay. Hey, that's it for this video. I hope that helps a lot. Continue on, and I'll be posting more quick vids as we go.